So this is a hard question because of all the possible equations you will end up with to give you this product of 27. So different ways that could happen is if this is 1 and 27, 3 and 9, 9 and 3, and then 27 and 1. Then you have to also consider the negatives. You could have negative 1, negative 27, negative 3, negative 9. So you have all these cases, and that's what makes this question difficult. And of course, if we want to maximize this, we want m to be positive and n to be negative, because we have a negative here. But you have to kind of wade through this. Obviously, they expect most students to kind of focus on that, and we know the solution is going to come here. But the work, I guess the underlying set of equations, and I'm sure most of you are familiar, but it's kind of tedious. I don't know if there's any other quick way to see it. At least I don't see it. So if you have to solve this, we double that. 2m plus 4n equal to 2. Then subtract the top from the bottom. You will get 3n is minus 25, and that won't give you an integer. So that one is out. That would be the case here as well. And then we're looking at the 3 and n, 3 and 9. And if we do that, 2m plus n is 9. Again, we double the top equation, 2m plus 4n equal to 6. Then subtract the top from the bottom. 3n is minus 3, n is minus 1. And then m would come out to be 5. If we plug that in here, minus 3 minus 1, that's going to give us 13. Now, if you look at the other solution here, 9 and 3, m plus 2n is equal to 9, and then 2m plus n equal to 3. Again, we double this. 4m plus 2n equal to 6. m plus 2n is equal to 9. Subtract them. 3m is equal to minus 3. m is minus 1. If we plug that in here, n turns out to be 5. In this case, the answer will be negative, but it gives you a clue. This would be minus 17. So what if we flip it? Because these two equations, when you solve for them, one will give you minus 13, the other will give you plus 17. So it's kind of tedious, and to do this under exam conditions is stressful. And you just, I mean, I guess that's what makes this question difficult. And as I've done this work, the answer will come out to be plus 17 when you consider that case here. So the answer is 17. I don't know if there's any quicker way to see the answer other than going through this. Maybe there is, at least. I don't know right now, but I'll think about it a little bit more. This is what I have so far. The answer is 17.